Assalamu alaikum, good morning and hi everyone. In this video, we will be presenting our work for MAT183 Assessment 2. In this assessment includes Arissa NUR'IMAN, QISTINA SOFEA, YASMIN ZAFIRAH, SITI DINAH HAFIZAH and NURUL ATHIRAH as the presenters.
Question 1. Explain the meaning of differentiation and what are the techniques of differentiation? Question 1.
Differentiation means finding the rate of change of a function. In other words, it helps us know how fast something is changing. For example, it can tell us the speed of a moving object or the slope of a graph. There are a few common techniques of differentiation. 1. Power rule used when the function has a power, like 2. Constant rule, the derivative of a constant is 0. 3. Product rule used when two functions are multiplied. 4. Quotient rule used when one function is divided by another. 5. Chain rule used when one function is inside another function. Each technique has its own formula to help us find the derivative more easily. That's all from me.
Find dy over dx for the following functions. A. 3x square sec x plus 2. B. y equal to 4x plus 2 over cos x.
Function 3x to the power of 2 seconds x plus 2. This is a product of two functions. The first one is u equal to 3x to the power of 2, and the other is v equal to sec x plus 2. To differentiate a product, we use the product rule. The product rule is the derivative of the first times the second, plus the first times the derivative of the second. The first step is to differentiate the u. Differentiate 3x to the power of 2 by multiply the 3 with the power of 2, and the power of 2 minus 1. So, the derivative of 3x to the power of 2 is 6x. Next, let's differentiate the v using the chain rule. The derivative of sec x plus 2 is sec x plus 2, tan x plus 2. Now put it all together. So, the derivative is 6x sec x plus 2 plus 3x to the power of 2, sec x plus 2, tan x plus 2. That's the final answer.
For the next question 2b, we are given two expressions. The numerator is 4x plus 2. The denominator is cosine x. We want to find the derivative of this entire expression, which means we're differentiating 4x plus 2 over cosine x. To do this, we use the quotient rule. The quotient rule says, the derivative of u over v is v times the derivative of u minus u times the derivative of v, all divided by v squared. Let's identify our parts. Let u be 4x plus 2. Let v be cosine x. The derivative of u, which is u prime, is just 4. The derivative of v, or v prime, is negative sine x. Now, using the quotient rule, we multiply v, which is cosine x, with u prime, which is 4. Then we subtract u, which is 4x plus 2, times v prime, which is negative sine x. The whole thing goes over cosine squared x. Now simplify the expression. Multiplying cosine x and 4 gives us 4 cosine x. Next, we're subtracting a negative, which becomes addition. So, we add 4x plus 2 times sine x. Putting it all together, we get 4 cosine x plus open bracket 4x plus 2 close bracket sine x, all divided by cosine squared x. And that is your final answer. Given y times ln 3x, minus e to the power of 2x, plus 1, minus tangent of 4y equals 0. Find dy over dx using implicit differentiation.
This is the solution for question 3 for the equation y ln 3x minus e to the power of 2x plus 1 minus tangent 4y equals 0. First, for the term y ln 3x, we apply the product rule. This gives us ln 3x times dy over dx plus y over x. Next, we differentiate e to the power of 2x plus 1, which becomes 2e to the power of 2x plus 1, using the chain rule. For the tangent 4y term, we also use the chain rule and get 4 seconds square 4y times dy over dx. The right-hand side of the equation is just 0, so its derivative is also 0. After differentiating, We combine all the terms. We group the ones with dy over dx on one side and the rest on the other side. Then we factor out dy over dx and solve for it. The result we get is dy over dx equals 2e to the power of 2x plus 1 minus y over x over ln 3x minus 4 seconds square 4y. This is how we use implicit differentiation to find dy over dx.
Now, let's solve the fourth question. Use linear approximation to estimate the value of the fourth root of 80.99 minus 2 over root 80.99 correct to 3 decimal places. Alright, first of all, we let fx equal to the fourth root of x minus 2 over the root of x, which means x is 80.99. So this will be x to the power of 1 over 4, and this will be x to the power of 1 over 2. So the whole term becomes 2x to the power of negative 1 over 2. When fx equal to x to the power of n, so our f prime x will be n multiply x to the power of n minus 1. Now we have 1 over 4x to the power of 1 over 4 minus 1 minus 2 negative 1 over 2 x to the power of 1 over 2 minus 1. And then we get 1 over 4x to the power of negative 3 over 4 minus negative x to the power of negative 3 over 2. So the derivative is 1 over 4x to the power of 3 over 4 plus x to the power of negative 3 over 2. Since the x, or the given value, is 80.99, so the chosen value, or the x0, will be 81. To get the delta x, we have to subtract x with x0. This means 80.99 minus 81 equals to negative 0.01. So now let's use linear approximation. Fx0 plus delta x equals to fx0 plus f prime x0 delta x. So the fourth root of 80.99 minus 2 over the root of 80.99 equal to f81 plus f prime 81 delta x. Then just change the 80.99 to 81. So let's calculate this one and this one. And we get 25 over 9 here, and 1 over 108 plus 1 over 729. And multiply negative 0.01. And finally, we'll get 2.777. And that's the answer.
In conclusion, differentiation is basically a way to figure out how things change, like how fast something's moving or how one thing affects another. It's super useful in math, science, and real life. There are a few methods like the power rule, chain rule, and product rule that help solve different kinds of problems. Once you get the hang of it, it really helps make tough topics easier and more understandable. This is our references. That's all from our group, thank you.